Hello, everybody. We're going to give folks a minute here to join. Thanks for taking time out of your very busy schedules. We know there's lots going on, so we always appreciate when you guys take the time to join us for these type of live sessions. So we'll just wait a little bit longer here, and then I'll go into the classic housekeeping spiel for you all. Seeing some familiar faces in the attendees, which is always fun. Familiar names, I should say. Okie doke. I am going to get started with housekeeping. So again, thank you everybody for taking the time to join us today. We're really excited to take you through the Twingate Kubernetes Operator. And I'm really excited to introduce our hosts and presenters today. So we have Eran, our VP of Engineering. He is going to be doing a live demo of the operator, so you'll get to actually see it in action. And then we also are joined by Anna, our head of product, and she is going to take you through a little bit about our approach to Kubernetes and what you can see from us in the future. So we're really excited about that. We are going to be sending out a recording of today's session after the live event. We just need to go through the kind of video processing stuff. So we try to get that out within 24 hours of the event. So keep an eye out for that. And then we want this to be interactive. So please submit questions via the Q&A. You can go ahead and test it out right now. Send me a hello and let me know where you're joining us from. We have a lot of folks that are, a lot of customers that are not from the US. So we know that the scheduling can be kind of a pain, and we really appreciate you guys joining us. We are going to have a bit of a kind of two-part demo. We will take you through the first part, pause for questions if you have any that come up. Then we'll take you through the second part and have the opportunity to ask questions again. So like I said, questions are very, very welcome. And we have someone who's already tested it out, Liam, who is joining from Dubai. So really appreciate you joining despite the time zone differences. Very cool to see you there. And with that, I'm going to hand things off to Anna.
All right. Hi, everyone. I'm Anna, head of product here. Excited to be here and share some of our latest announcement with Kubernetes. So as Em mentioned, we're going to do the overview and demo of our operator. We'll highlight why we're so excited about Kubernetes generally and how you can go about getting started. So to kind of kick us off, if you haven't heard of us before, Twingate is a zero trust access solution that's focused on making it easy to actually implement a zero trust security model. Over the past year, we've grown significantly, so we're so excited to share that we, secure billions of connections monthly. We serve over 2,000 paying customers. All of this while maintaining a reliability. We know that Twingate is a foundational piece of infra in your organizations, and you need us to get work done. So because of this, as we scale, reliability is really the most important thing, and it's core to how we build products. So we're very proud to say that we hit, that 99.99 uptime. And so taking a step back, Twingate's mission is really to make it easy to work securely from anywhere in the world. So to achieve this, we focus in on the central question: who can access what? The question seems pretty straightforward, but in reality, it's not that simple. Right? The who and the what are getting more and more diverse and complex every year, and it's important that the products that we build allow you the flexibility and control to not just answer the question, but also to be prescriptive about that answer. So as part of this, we've been focused on building a flexible and high-performance platform that integrates with your existing stack and doesn't get in the way. So we cover all aspects of ZTNA so that you can be confident that only your users are able to securely access what they need and not more than that. We know that your ecosystem of solutions is complex, so we support that by integrating and working with common tools that you may have already implemented in your organizations. And over the past few years, we've really worked to become that platform by, one, linking seamlessly with the full spectrum of tools, and two, covering functionality that spans private access and beyond. One of the tools that's been continuing to increase in popularity, and what you're all here for today, is Kubernetes. So let's start with a quick review of Kubernetes and why it's become the backbone of modern infrastructure. Kubernetes is just an open source platform that helps teams to deploy, scale, and manage containerized applications. It's now the standard for running workloads in the cloud and on prem. One of the key benefits that we see ourselves and hear about all the time is the automated operations. So, Kubernetes can self heal when nodes or containers fail. It can intelligently balance traffic and scale services horizontally, all without needing manual intervention. It can provide powerful infrastructure abstraction, which means your applications can run consistently across different environments, whether you're in the cloud, on-prem, or hybrid, without needing significant rewrites or re-architecting. And finally, Kubernetes uses declarative configuration. So instead of scripting every step, you can define your desired state in code, and then Kubernetes can figure out how to get you there and stay there. So this combination of automation, flexibility, and consistency is why Kubernetes is such a game changer. We use it heavily internally, and so wanted to just make sure that we're all on the same page and all have that background about why Kubernetes has been so exciting over this time. And Kubernetes really has become the critical infrastructure powering innovation in today's software landscape. So it's the foundation of modern infrastructure and the de facto standard, really, for orchestrating containers at scale, especially in enterprise environments. And that's because Kubernetes provides the scalability and resilience that modern apps demand. So whether you're deploying microservices across clouds or rolling out global infrastructure, Kubernetes can give you the tools to do it reliably, repeatedly, and efficiently. So it's the layer that allows, your teams to move fast, stay flexible, and build with confidence, even in the most complex environments. As we look to the future, Kubernetes is also positioned to become the backbone of AI workloads. So AI isn't just one type of workload. It spans everything from, model training and inference services to distributed computing, GPU accelerated tasks. Each of these has unique demands, but they all share critical infrastructure needs, especially around scalability and resilience. So that's where Kubernetes shines. It can dynamically scale resources up or down based on demand, distribute jobs efficiently across compute nodes, and recover automatically. So whether you're running a single model or orchestrating an entire pipeline across GPUs and CPUs, Kubernetes can provide a consistent, flexible foundation to support AI at scale. And this is especially neat with upcoming projects like Kubeflow coming up. So in short, Kubernetes doesn't just support AI, it really is enabling it to run more reliably, efficiently, and anywhere. So we see Kubernetes as a critical part of both today's infrastructure and the future. And that's exactly why we're excited to bring it into the Twingate platform. Securing access to and within Kubernetes environments fits naturally into what Twingate already offers, especially when you think about that connect phase of the access lifecycle. So our goal is to make it easier to deploy, manage, and secure your Kubernetes environments so that your users can connect seamlessly without compromising on security or performance. Our operator is focused on just that. So at this point, I'm going to pass it over to Eran to speak more about our operator and its capabilities and walk us all through that demo.
Thank you, Anna. Let me share my screen. Okay, so what is a Kubernetes operator? When you look at the Kubernetes at a high level, right? Basically what Kubernetes is, it's a database for YAML objects or for objects that you can represent in YAML, and an API that lets you listen to events on those objects. Right? Of course, there's way more detail than that, but very high level, that's what it is. It also allows you to, it also supplies you with some building blocks to run workflows, basically handle containers, deployments, and stuff like that. So an operator is just a piece of software that can define, that listens to events made on these objects, either the Kubernetes built-in objects, or it can define its own objects and react based on those triggers. So you've probably seen or used like a Grafana operator. It listens to config maps that have dashboards in them, and when they change, it just syncs the dashboard to Grafana, or Prometheus operator that syncs rule objects to Prometheus. That's basically an operator. And if we think about Twingate and what the Twingate operator, so first let's cover some basic concepts in Twingate, right? So we have the Twingate connector, which is a piece of software that runs in your network and allows configuring access to workflows or workloads that run in that network. And we have the client that is connecting to the connector to be able to access to those workloads. And the idea with operator is to allow you to configure how people can access to different resources in your system programmatically using Kubernetes objects. If we take a step back for a moment, Twingate is one of our missions as Twingate is to be very engineering organization friendly. So we're API first. All our features are also exposed in our public API. And we want to enable or empower engineering organizations to automate and configure access in the platform that they're already using, right? So if you're using Terraform, we have a Terraform provider that lets you configure access on the Terraform resources as you configure them or write them in Terraform. And the goal is the same with the operator, right? You have a service that you're already using Flux or Argo or Helm to deploy. It's a Kubernetes service. And we want you to be able to configure how to access that service as part of that deployment process. So with that, let's go to our demo. So exit the presentation. Okay, so this is my Twingate tenant, right? I have a Twingate, and I have this remote network. I called it my Minikube. I'm running the operator on my Minikube that runs on my laptop. And as you can see, this network is offline. It doesn't have any connectors or resources or anything. And I want to start configuring it. So the first thing I want to do is set up a connector for that network. So to set up a connector, basically all we need to do is define an object called Twingate connector, and we give it an image policy, which is a schedule when it auto updates itself, right? So when a new connector gets released, we want it to auto update. We give it a schedule when to check because we don't want it to randomly restart during the workday, for example, right? So we have this YAML, and all we need to do is apply it to our Kubernetes, Minikube in this case, and see what happens. So if I go to my terminal, let's ignore this side. I have my terminal here, and I'll do kubectl. Let's see, make sure it's big enough, right? So kubectl apply -f our connector YAML, and as you can see, I have a connector. It deploys a connector object to my cluster. The operator sees that it has a new Twingate connector object, and it provisions it on the Twingate side. So if I go back to my tenant and I'll refresh the screen, you'll see now that my network is online and I have one connector connected. If I go to Kubernetes, I can do kubectl get Twingate connector, and I'll say I have one connector, my connector. It has an ID, the ID that got created on Twingate, and it has a display name. And you can see that connector object also created a deployment. So kubectl get deployment. So we have the deployment that matches my connector, and if we do kubectl get pod, that deployment runs a pod for that connector. And that's as easy. That makes it very easy to deploy a connector on Kubernetes. So for example, let's say I want another connector, I can just go to this YAML and let's duplicate this and call it my other connector. And we'll give it a different schedule because we don't want both of them to restart at the same time if there's an update. My other, we'll give it a name too. We'll save it and let's apply it again. kubectl, apply F. And now you'll see kubectl get TC. TC is the shorthand for Twingate connector. You can use that too. You can see I have two connectors. They both got provisioned and got an ID. And if I look at my tenant and refresh the screen, you'll now see that my network is still online, and now I have two connectors. And then the operator will continue running. It checks every day because that's what I set it. It checks for a new version. When there's a new version, it will auto-update it. So the operator, in this case, makes it really easy to install a connector and have it auto-updated. Any questions about that?
Yeah, if we have any questions, go ahead and submit them about connector deployment with the operator, and we will get to them right now before we head into the second part of Eran's demo. So let's see if anything's come up.
I think if not, we can continue and handle questions at the end.
Okay, cool.
Yeah.
If something comes to mind while Eran's started on the resources section, feel free to submit it and we will get to it at the end.
Okay, so we have our network configured, and now we want to actually configure resource to be accessible on that network, right? So imagine you have like a service you're working on, let's say a Flask or something, and you're deploying it with Helm or with Flux or Argo. So you'll probably define the service, so you know it has an internal address in Kubernetes, and you can just create a Twingate resource that encapsulate that address, right? So we create an object of type Twingate resource. We give it a name, my Twingate resource. We can add a bunch of labels to it, like foo bar, and then like any resource in Twingate, we can give it like the display name, and we need to give it an address so we know how to access it. We can give it an alias, we can add port restrictions, anything you can do in the UI, you can do here. So this is our service. Let's go ahead and kubectl apply -f our resource. And if we do kubectl get Twingate resource, you can see that my resource got provisioned in Twingate. It has an ID. And if I go and refresh my screen here, we have our resource, right? And if we look at that resource, we can see it has two tags and local foo bar that I just added. It has the address that I configured and the alias, right? And the nice thing about this is because the connector is running inside Kubernetes, and this service is running inside Kubernetes, we allow our clients, the client devices, to access this service, and we don't need to expose it to the internet. We don't need to define a load balancer or anything. The traffic goes directly into the connector, which is inside the Kubernetes cluster, and from the connector, the traffic goes inside the cluster to the relevant service. So the next thing I'm going to show you, or the next question we usually get here is, if I already have a service that I'm deploying to Kubernetes, I define the service object so that I get this address, and so that I can enable accessing to that service. Why do I need to create a Twingate resource object and you can just read my service object? So we can. So if you want, you can manually define a Twingate resource and it'll get created. Or if you already have a service object, you can choose to annotate that service, right? So here I have a regular Kubernetes service. It has a name, my service, and it has like a bunch of selector which pods to forward traffic to, and a bunch of protocol definitions. And all I need to do to expose this service to Twingate is to define a bunch of annotations. So basically resource twingate.com true means let's sync this service as a resource to Twingate. And then I can customize a bunch of stuff that's not part of the service spec, right? So for example, alias is a very Twingate specific thing, so I can customize it with annotations. So we have this service object, let's create it. So kubectl, apply, service object. So now you can see get svc, oops, kubectl get svc. We have our service. We can do kubectl get svc YAML. This is our service with the annotations. And you can see the operator saw that there's a new service with our annotation, and it synced it to Twingate. So if I go back to Twingate and I go back to my network, I logged out. Sorry. Okay, so I go back to my remote network, my Minikube. Sorry, let's recreate it. It pre-existed from a previous demo. So again, kubectl, apply, F, step 3. We have our service. And if we do get Twingate resource, we'll see the service created a service resource, and that resource got provision. Right? So the service creates the Twingate resource for you. So if we look at the Twingate, at this Twingate resource, kubectl get tgr, it's the shortened for Twingate resource, -o YAML, we can see that basically we created a Twingate resource object, and we basically deduced all the Twingate related information from the service object, right? So we have the port restrictions and all that stuff, and we have the alias that we customized via an annotation, right? So if we refresh the screen here, yes, my Kubernetes service resource, right? So, and the idea is you're already writing your Kubernetes services in a certain way. With a simple annotation, you can have them sync to Twingate, and you can start configuring access to them. And now the last part is how to configure access to them, right? So you can do it manually via the admin, like go to the resource and configure who can access it, but you can also do it programmatically. So the last thing I'm going to show you is how to configure access using Kubernetes too, because so we have a Twingate resource access object, and in that object, I reference an existing resource, my Twingate resource that we created in the previous step, and I can provide access to it to a certain group. So in my case, I want to give my Twingate resource, I want to give access to the engineering group to access it, right? So this is the object. Let's go and apply it. kubectl, apply, -f, step 4. So we created an access object. And if we go and refresh, this is not the right resource. This is my resource, and I gave it access to engineering, and now it's there. So that's what we wanted to show. And the bottom line here is, again, you have existing development workflows. We don't want to disturb them. We don't want to tell you go talk to IT whenever you deploy a new service, or go talk to DevOps because it needs to be Terraform. Twingate wants to be part of your already existing development flows, right? So if you're developing a service for Kubernetes, and you're already defining a bunch of YAMLs, and we give you the Twingate specific YAMLs, you can add and augment your deployment to automatically configure accessing to your service on Twingate.
Okay, awesome. We're going to take another quick Q&A break before we hand things back to Anna. A few questions came in about connectors and a few about other things. So again, if you have any questions about what Eran just showed, please send them in. Okay, first out the gate, we have a question that says, if we enable the connector update and we have two connectors, then will both update at the same time, or can we be sure that one will always update? And I think they're essentially asking, can you ensure that if you have two connectors, they are not updating at the same time?
So you cannot ensure it at the operator level because each connector is independent. You have to ensure it by setting the schedule to be different. So in the example I showed earlier, I set this connector to check for update every day at 12 a.m. and this one checks 10 minutes after. So this way I ensure that, if there's an update, this one restarts at 12 a.m., takes a couple of seconds to be back. By the time 10 minutes pass, this one is already updated and this one will restart.
Amazing. And then as a reminder, this is probably old news to folks on the line, but we do typically recommend having two connectors deployed, particularly for that kind of like backup ability to always have connection maintained. Okay. Let's say here's another question from Victor. Let's say I have three clusters for dev, UAT, and prod. How do you suggest we properly route between them if all clusters have star.cluster.local as their internal host name?
So that's why we introduced the alias thing. So let's say you have a service. Let me write here, right? Let's say you have a service, foo.svc.default.cluster local, right? And you'll have that same service in three different clusters. To differentiate, when you create the resource to differentiate between the different clusters, you can give them different aliases. So for example, you'll have foo US Central, foo US East.int. So when users want to access this service on their client, they're not using this address because this address is ambiguous. All the three resources have it, right? So let's say, I don't know, foo US West, right? So if they try to use this address, it's ambiguous. They'll reach one of them. We can't guarantee which one. We just choose one at random. If they use the alias to access that resource, then that's what differentiates them. So yes, that's the purpose of the alias feature.
Okay, awesome. We have a question here from Ahmed. Is the operator a substitute to the existing connector for Kubernetes?
It's not. So we have lots of ways you can deploy a connector, right? You can deploy a connector using the connector Helm chart. You can deploy it using Terraform, and you can deploy it using the operator, right? So you have many options, and the idea is you choose the one that fits the way your engineering team works the best, right? So engineering teams where they provision the clusters with Terraform will usually choose the Terraform one, or use the combination of the Terraform and the Helm chart. Like the Terraform runs the Helm chart. Some organizations, they only provision the cluster in Terraform, but then they use Flux or Argo to provision anything inside the cluster. For those organizations, the operator would help because Flux looks at Kubernetes objects. Yeah, so it's really up to you which method you want to do. The difference is in the other methods are one time, right? You deploy a Helm connector and that's it. There's no monitoring component for it. So the added feature of using the added benefit of using the operator is that you have the operator that continuously monitor the connector and can take care of auto updating it.
Okay, awesome. We have another question here from Liam. Is there a plan to make the operator inherently high availability? Example, deploying one connector per node.
High availability for us is like if you have at least 3 connectors on different nodes, that should be enough. You shouldn't have connectors on nodes that go up and down, because connector going up or down is a disruptive process, right? It might disconnect clients, or they need to reconnect, they need to open connectors. So you actually don't want connectors as like highly available, auto-scaled, going up and down all the time. You want them to be more stateful, I would say, like a database. So we recommend like 3 connectors. But yeah, I hope that answers the question.
Okay, cool. We have another one here. Can you use the CRDs to manage resources and access outside of the cluster? Example, I want to add an external database on AWS. Can I use an in-cluster Twingate resource, or should that be done with something else like Terraform?
Sure, you can. So just another thing for the previous question. So I only showed the basic like properties of Twingate connector, but there's a lot of customizations you can add. So you can add pod extra or pod extra and add like extra stuff you want to be added to the pod on the deployment, like environment variables or annotations if you want to, I don't know, send logs via Datadog or something. So you can customize like the toleration and make sure that connectors don't get deployed together. You can do that using that. Now to the question of managing resources outside the cluster with objects in the cluster. So yes, you can. That's why we have the separation of, you can annotate services. That's for workloads that are running inside the cluster. Usually you have a service object, you just want to annotate it. But if you work directly with a Twingate resource object, the address here could be anything. It could be, my AWS db.example.com, right? So you can use this to synchronize any resource basically to Twingate, right? So yeah, you can, and again, so you should do that or use Terraform depending on what fits your organization better. I know a lot of organizations obviously use Terraform because they provision the database using Terraform, and then they want to configure Twingate right next to it in the same code, in the same module. But I know other organizations, the more Flux or Argo focused ones, they have like an infrastructure cluster, and they just provision it with Terraform, and then they provision everything else in their environment using operators and YAML objects on that infra class. And then they use objects like this for that.
Okay, one more question before I hand things off to Anna for one extra little bonus for you all on the line today. Again, we're gonna save time for Q&A at the end as well. Like I said, this is meant to be super interactive. So thank you to everyone who has continued to submit questions. We will try to get to all of them after Anna speaks. So last one for this section, can we set up resources with just-in-time access using the operator? Oh, you're on mute, Eran.
Sorry, I'm on mute. Yes, so you can set it up with just-in-time access, or if you're configuring a bunch of security policies, you can just add security policy ID here and point to the policy that you want this resource to have, right? Just like in the UI. Also, so we have default resource policy, but also when you configure access, I have a zoom issue here. When you configure access, you can also override the policy here. So you can also add here security policy ID. whatever, and that will override the security policy for that access. So you can say something like engineers require, let's say this is the ID for the MFA policy ID. So you can say here, engineers require MFA to access this resource, but everyone else in the resource, everyone else only need the SSO, right? Security ID, something like that.
And for these policies, can folks configure policies using auto lock or ephemeral access?
Yes.
Okay, cool. Quick refresh for folks who maybe aren't familiar with Twingate. You can automatically revoke access at like a set date or time. We call that ephemeral access. We also have auto lock, which is really cool. We're really proud of it. It is gives you the ability to set essentially usage limits, use it or lose it requirements. So we have some variations on what kind of time and usage bound access looks like, and you can get pretty granular with what those policies are. So with that, we're going to put
Wait,
pause
just
on.
one correction. I'm not sure about ephemeral because ephemeral doesn't really make sense in this context, right? So imagine you create this object and you don't want the object to be ephemeral. You create the object, it exists. As long as it exists, you want to make sure the object itself isn't ephemeral. It doesn't make sense that it would represent ephemeral access, right? So we don't support ephemeral access in these objects, but the other stuff Autolock we do.
Cool. With that, Anna, handing it back to you.
All right. So Eran, I'm going to take that screen share again. All right, thanks so much for that, Eran. So we're super excited about the operator and can't wait to hear how it works for your teams as you start rolling it out. So far, we've really focused on securing access to Kubernetes and the services running within it. But when you look at the full access lifecycle, so going back to this slide, we know that there's a lot of other critical phases that we want to go deeper on. So authentication, authorization, auditing, and all the workflows that connect them all. So in the second half of this year, we're excited to expand beyond just securing access and going deeper into the cluster itself. So helping you control and observe how access is granted, used, and monitored end to end. So to make this all possible, I'm happy to share that we are working on Kubernetes Access. So extending Twingate to act as an application-aware proxy. This means that Twingate will authenticate users and enforce access policies before any request reaches your cluster. And with this approach, users can access clusters without needing separate credentials, and you get better visibility and auditing into what actions are being taken actually on the cluster. So revisiting the architecture diagrams from earlier, as Eran mentioned, you have the components that we already support today, the Kubernetes cluster, the Twingate operator, your resources, your users. What we're adding is a gateway that all activity passes through. So this addition unlocks two key capabilities. The first is authentication is seamlessly handled by Twingate, so users can securely access the cluster without friction. And two, that activity is logged and auditable at the gateway level. So it gives you the observability you need for security and compliance. So let's actually dive in and kind of see a video on how this works in practice. So I'm going to switch my screen share. Okay. Can everyone see this? All right, got a thumbs up here. So this is the Twingate admin console. You can see here that we have a remote network that represents the Kubernetes cluster. And within that network, there's a resource that's pointing to the API server. And so this resource configuration means that the API server isn't directly accessible from the internet. Twingate doesn't need any open ports or open inbound ports. And so the API server is invisible to the open internet. And users are connecting through Twingate and applying the security policies that we support. And so from this, we saw the Twingate client interface, and the Kubernetes cluster appears as an available resource. So actually go back just a little bit, just because that was pretty quick here. Yeah, so from here, the Twingate client has that Kubernetes resource, and we're actually going to sync the Kubernetes configuration. And it's configuring the kubeconfig file with all of the settings. So there's a context called with the cluster with the correct cluster, the definition points to the Twingate resource, and then the user section contains the authentication that Twingate will handle. But now users don't need to provide that separate Kubernetes credentials or authentication tokens, and Twingate's communicating the identity directly to the cluster. So here we now have kind of the terminal that's connected to the cluster through Twingate on the left-hand side. And on the right-hand side, for demonstration purposes, we've got that Kubernetes Access gateway logs. So you can see what's happening behind the scenes. So we can start with running whoami to verify the identity. You can see that the Min2's identity is actually getting passed through. And if we run through some typical commands like get pods, get services, you can see that each request is being attributed to Min2's identity. So it's very easy to see who's doing what within the cluster. If we go on to some more advanced capabilities, with starting to list out some files, make some changes, the real power is actually still when we get into those activity logs. So when that session ends, Twingate is capturing the entire session in an ASCII NEMA format, so you can replay it and actually see everything that's happening there. So this makes it very easy to do things like investigate any security incidents. You can share knowledge more easily. And then you also are meeting compliance requirements that help you or that require you to have those detailed logs. And so this is what we are hard at work on. We're really excited to share everything we've been building around this Kubernetes Access, and we can't wait for you to try it out. If this is something that you're excited about, the best way to get started is with our Kubernetes Operator. It's the easiest path to get up and running with Kubernetes Access as soon as it becomes available. And also, don't forget to subscribe to our early access program. You'll stay up to date on the latest developments and be among the first to try out kind of these new features as we roll them out. Okay. And with that, I think we're going back to a final Q&A
Back
here.
to Q&A. Keep repeating it, same thing over and over. But again, we want to hear what you guys need clarification on, what you want to learn more about. So first out the gate, are the upcoming features around session recording of kubectl commands, etc., going to be an included feature or an additional paid add-on?
So we will have some basic usage available for everyone to get started with. And then as we expand out our capabilities around access, supporting more protocols, adding more functionality, those will be paid add-ons.
Okay, cool. One that, Eran, you've kind of already covered, but maybe just like a little dedicated. Why should our team choose the operator versus Terraform?
So yeah, like I said, it depends on the engineering workflow that provision the said resources. If the resources are provisioned or the services are provisioned by Terraform, usually you'd want to configure the access right there in Terraform next to where you define those resources. If you're using Helm or Flux or Argo to deploy your services, you'd want the Twingate settings to be as YAML objects next to that, right? So mostly depends on your flow and what feels comfortable to you.
Okay, cool. Few questions coming in about getting started, availability, that kind of stuff. So we have shared the operator previously as a beta tool. So when is it going GA and how can folks get started using it?
So we're going to GA with our Kubernetes operator later today. So stay tuned. We're going to be pushing that out in just a bit. And as for getting started, the right place to go is we have a GitHub repo with all of the information there with instructions, documentation, and also if you have any issues that you run into, we are also very responsive. Eran will probably be directly responding to anything that you bring up there.
Cool, cool. And then Eran was directly replying to a few folks who submitted questions, but I think it's always useful to share with the group. So one question that came in was, if connectors have pod anti-affinity set up, will the update cron be able to be scheduled without having to manually delete an outdated pod?
Yeah, so the answer is what the Twingate connector object does is create a deployment object behind the scene, right? And when you update the object, like let's say you add an annotation or a label, or when there's an update to the image, what it does behind the scene is just patch that deployment object, and we let Kubernetes do its thing with managing the pod. So like any deployment change, it will trigger a rollout, and Kubernetes will delete the pods and reschedule them based on the affinity rules, toleration rules, whatever's in the deployment.
Okay, cool. Question here from Jacob, who joined late. So quick call out for you. We will be sharing a recording of this so you can catch up on everything that you missed. But Jacob's question is there a way to manage access to specific namespaces within a cluster?
Interesting. So our Twingate resources let me share my screen, it'll be easier. 1 second. Two. Okay, so we have a Twingate resource object. A Twingate resource can actually have wildcards, right? So for example, let's say I want to expose access to an entire namespace. I could do something like star.svc.my_namespace.cluster.local. The thing is, once you have wildcard, you can't use an alias, right? So if you have, like the previous question, if you have multiple clusters with this exact address, you need to find a way to distinguish between them yourself. Like instead of using cluster local, set up your Kubernetes to, use another DNS prefix like US central local. Right? But Twingate does support wildcards in the address. So it's kind of a solution. But again, with being zero trust, we recommend that you be as specific as you can when defining resources, because it gives you more control and more granularity on who can access what.
Okay, cool. We got another question coming in. Currently, we use public connectors on an IP whitelist for access to AKS clusters. And now we can switch to using connectors in the cluster, which is great. Can we specify a secondary or fallback remote network for resources in that cluster in case the connectors inside the cluster are offline? We can't have a situation where we lose kubectl access, which needs to require Twingate to a cluster.
You can. So basically, the fallback, so you just need to deploy another connector in that same network, but you deploy it outside of the cluster in like a VM or something. But ideally, I don't think that's necessary, because as long as you deploy multiple connectors inside the cluster, and you let Kubernetes handle like rescheduling, like let's say a node goes down, it reschedules the pod in another node. It would kind of take your entire cluster to be down for those pods not to be scheduled. And then you won't have kubectl access anyway because the cluster is down. So yes, you can, but I'm not sure why it would be necessary. But again, different companies have different setups, so maybe in your specific case, it makes sense.
Okay. Last call for questions before I let everyone go. So make sure you get those in. If we don't get to them live today, we'll reach out after the event. So final call to submit your questions. Here is one. Can I use annotations to do access management?
Not yet, because we didn't find a nice way to define it. So annotation is just a string. And with a string, so you can have a string with a JSON inside it that defines which group or which service account gets access to that resource and via what policy. But then it becomes really complicated and hard to do error management, right? So with Kubernetes, when you define objects, we like to be as explicit, type explicit as we can. And you can't do it with annotations, right? Annotation is just a string. I can define like a JSON schema that you need to put in that string that would specify all these accesses, but it would be too error prone. And that's why we chose to use objects instead.
Okay, cool. Awesome. With that final kind of wrap up, just a reminder for folks of where and when they can find all the stuff that we shared today. Anna, Eran, who wants to take it on?
So everything we shared today about the operator, so the operator is open source. You can go to github.com/Twingate and see the operator repo. Inside, there's a README that explains everything. There's a wiki there with a getting started guide that shows you how to set up the operator and takes you through the basic steps of setting up a connector and the resource, basically what I showed today. And in the issues, if you have any questions or a problem or a bug, you can submit an issue and we're very responsive there. And if you have more general questions about Twingate, you can always go to our Reddit community where a lot of Twingaters monitor it and you'll get answers very fast if you ask something. Not just from Twingaters, a lot of questions get answered by the community itself, which is very nice. Yes, anything I'm forgetting, Anna?
Final piece, I'm going to steal the screen really quickly. So our head of solutions engineering, Bren, hosts a monthly office hours session. Some of you may have already attended, but if you have any, is everyone seeing my screen?
Yeah.
Okay, great. If you have any questions, after you have a chance to go through the install guide, the wiki, play around with it yourself, I'm sure more questions will come up and we want to have an avenue for you guys to ask them. So we really encourage registering for this and joining. You will be able to actually talk. So it's not just going to be Bren presenting at you. It's meant to be like a true office hours. And so our next one is going to be on May 29th. So gives you a little over a week to play around. And again, Bren's the best. He is ready and waiting for your toughest operator questions. So in addition to the Reddit community, highly recommend joining this. And with that, I will let everyone go. Thank you all so much for joining. Keep an eye out for the recording. And a big thank you to Anna and Eran. Bye, guys.
Thank you.